Okay, so today we are going to do the differentiations of powers of x. So differentiation, once again, is actually finding the gradient. So how do we find the gradients of a function? Okay, like this. Okay. So what is the power of x here? 1. So the trick is this. In order to differentiate y with respect to x, or rather just dy dx, bring down the power minus 1. You keep on hearing this for the whole year. Right? Bring down the power minus 1. Okay, let's bring down the power. So I bring down the power, right? And then the power minus 1 becomes 0. What is x power 0? It's actually just 1. It is a diagonal line that passes through the origin at 45 degrees with respect to the x-axis. Because the coefficient of the linear graph, the coefficient of x is 1. So the gradient is 1. Dy dx work. What is the trick to find dy dx? Bring down the power minus 1. The next question, we are going to find, write down, you have your resource book, dy dx. Let's differentiate the first term, 9. If you don't understand, then just ask yourself, gradient of y equals to 9, what is the gradient? Y equals to 9 is a horizontal line, right? Y equals to 9. So when you differentiate it, the gradient is 0. Do you write 0? Okay, but because of we are just introducing the lesson, so I put a 0. So now let's differentiate the second term. Negative 5x. Bring down the power minus 1. Negative 5x. The power becomes 0. So x to the power of 0 is 1. So what's the final answer? Negative 5. Must you do until so tedious? No, right? So we can straight away. Whenever you differentiate a constant, it becomes 0. Now, why is that so? Let's have a constant here. Y equals to a constant. A constant actually has an invisible x beside it. What is the power of the x? 0, right? So what is the thing you need to do when you differentiate? Bring down the power minus 1. So what number will you get? Negative 1 for the power, but the 0 times k, so the whole thing becomes 0. 2a. Now for 2a, I have a function fx equals to 3x squared. Okay, look up. This is how you differentiate a function with fx. You write a f prime x. Okay, so this is gradient. F prime x is a gradient. If the question is y, you write dy dx. If the question is fx, you write f prime x. Bring down the power, okay, and the power minus 1. So Jingyi question was, what do I do with these two numbers? I multiply. So what will we get? X. No more 5. Yeah, no, the 5 don't have 5 eh? Where do you get 5? Okay, now you know, huh? All right. So 2b, fx equals to x cubed. Okay, what is f prime x? I will call it as f prime x. Jacob. Bring down the power minus 1. So people do like that. Change the square root to power half. Good idea. Okay, let's try that. Let's change because nobody like a surd form for some reason. What will you get for the first term in the numerator? 3x. Oh no. Okay, I read to you. This is a 2. This is a half. So what power do you get? Law of indices. 3/2. Okay, let's speed it up. 1 minus half is half. And then this one, yes, I will have negative half. 1 over this is power negative half. Okay, let's differentiate now. So now then you put dy dx. Don't anyhow put as and when you like. Now that I put dy dx. Okay, let's do a rundown quickly. Leia. Yes, 9 over 2. Half. Very good. Okay, next, Jimmy. The bring down the power. No need calculator. This one. Bring down the power.
Half
Plus or minus?
half x. Oh, negative half.
Okay, finally, Jali. Plus or minus? Okay, very good. Now let's simplify it first. 2x squared. Okay, so how many x now? 1x. So plus x after I simplify. And what's the constant? Minus 1. Now I differentiate. So I write. Please have your presentation done properly. When you differentiate, I want to see dy dx. I'm going to penalize you during WA if you anyhow put dy dx. Tell yourself, I'm going to differentiate now. Dy dx. Okay, let's continue. Alicia, first one. Okay, well done. Then, Moshe. Okay, good. And finally, Dennis. Yeah, 0. Okay, so we are done already. In summary, when we differentiate, all right, when we differentiate the power of x, you bring down the power minus 1. Next, can you just take note? You can take a snapshot if you want. When you differentiate a constant, it becomes, Dennis, how much? When you differentiate a constant, what do you get? 0. And that concludes our lesson. Okay?